Okay, so here we have cube roots. So they want us to find the cube roots. So we're going to talk about cube roots and square roots real quick. See if I can get this right. So you remember it with squares, right? This is not a very well drawn square, I'm sorry to say. Maybe I should try to erase that. Let's try it again. Here we go. So if I did a square, right, and I made it, an exact, square, which this is not, but if I did, and this was 5 units by 5 units, then there would be 25 what we call square units in area there, right? And we would write, 5 times 5 is 25, and 5 squared is 25, and so then there's this relationship between 5 and its square, which is 25, and we say that if 25 is the square of 5, then we say that 5 is the square root of 25. So now what I want to think about is what happens if I go back 5 units this direction and turn this from a square into a cube. So now I have a cube that is not only 5 by 5, but now it's 5 deep, 5 wide, 5 tall, 5 deep, right? So that'd be 25 square units here, and then there'd be 5 sets of them. So it'd be 25 times 5, which is 125 cubic units, right? Not square units, but cubic units, because now they're going in 3 dimensions. So we can use the radical to go back. If we say 5 times 5 times 5, it would be called 5 cubed. That would be 125. So there's a relationship between 5 and its cube, which is 125, and we say that if that 5 is the cubic root of 125. The way we write in math, hey, let's find the cubic root of something, is we say, look, we use the radical again, but now we have to write the little number 3 up here. You should be able to see that. We're saying what is the, take the third root of that, or the cubic root of that. So we're thinking about 64 units, and in 3 dimensions, so they're cubic units, so how big would it have to be? So it's good for us to know, 1 times 1 times 1 is equal to 1 cubed, and that is equal to 1, right? So it's good to just sit there, and what are the other ones? 2 cubed. Well, 2 times 2 is 4, and 4 times 2 is 8. So 2 cubed is 8. 3 cubed. 3 times 3 is 9, right? 9 times 3 is 27, so 3 cubed is 27. I think before I even did this exercise, I would just write them down, write all the cubes down, and kind of start to recognize them. It's good for your brain to know what they are by practicing them a little bit. 4 times 4 is 16 times 4 is 64. So I can make a perfect cube out of 64 with sides that are 4, 4, and 4. So that's going to be my answer to this problem. But I'm going to keep going. We already said 5 cubed was 125. So what would 6 be? 6 cubed. Well, 6 times 6, that's 36, right? And then 36 times 6, it turns out, is 216. 216. How about 7 cubed? Well, 7 times 7 is 49. 49 times 7 is 343. 343. There we go. How about 8 cubed? Well, 8 times 8 is 64. And 64 times 8 is 512. 9 cubed. 9 times 9 is 81. 81 times 9, 729. 10 cubed. 10 times 10 times 10 is 10 times 10 is 100. 100 times 10 is 1,000. So 10 cubed is 1,000. By the way, the tens raised to any power, if you count the zeros, that tells you what power it's been raised to. So 1,000, 10 cubed. How about 11 cubed? I don't know in this exercise if we're going to go as high as 11 or 12, but usually with our times tables we try to learn those. 11 times 11 is 11 squared. That's 121. And then we have to figure out what is 121 times 11, and 121 times 11 is equal to 331. Okay, so that's a good number to know. We'll do one more, which is 12 cubed. 12 times 12 is 144. It's 12 squared times 12, and we get 1,728, which is 144 times 12. Okay, so now that we know these, we've got them written down. If you write these down on a piece of paper, getting this exercise done is going to be a piece of cake. Let's see if I can do this real quick. So 64, the cubic root of that is 4. Okay, let's go to the next one. And the cubic root of 27 is 3. Cubic root of 216 is 6. Cubic root of 343 is 7. Cubic root of 125 is 5. And there you have it. Piece of cake. So write them down and you'll be able to get this exercise done super easy. Then just try to remember them.